Good morning, guys. It is a great day to be in room 625. It is. Today, we are going to learn more about functions. I know earlier we had talked about functions. I Zoomed with a few of you guys. But I created a new presentation real quick just to review what a function is one more time before I give you guys your assignment. So the definition of a function is a function f from set A to set B is a rule of correspondence that assigns to each element x in set A exactly one element y in set B. Set A is the domain or the set of inputs, those are our x's, of the function f, and set B contains the range or the set of outputs, our y's. So what a function is, in more layman's terms than that, it's a relationship that has one-to-one, where every input has exactly one output. Mr. Sellers had explained before that in, I think, I can never remember the name of the movie, either Chicken Run or Chicken Little. The farmer has a machine, and he puts a chicken in the machine, out comes a pot pie. He knows that every time he puts that chicken in, out comes a pot pie. That is a function because that's a one-to-one relationship. He knows when chicken goes in, out comes pot pie. If he put the chicken in and out came a pot pie, and the next time he put chicken in, out came fried chicken, that's not a function because that's a 1-to-2 relationship. He doesn't know what's happening. He doesn't know what the output would be given as input. So whatever we do, whatever our input is, it has to have only one output in order to be considered a function. And we're going to talk about some of the stuff coming up. So the first thing we have to do is decide, is this a function? Then we're going to label the domain, and then we are going to label the range of these items. It is a function if every input only has one output. So if our input's 0, what's our output? -7. Do I have any other zeros as inputs? No. Input 2, output 5. Do I have any other inputs of 2? No. Input of -3, outcomes 1. I have no other -3s. Here's -8. It has an output of 0. I have no other -8s. So that is a function because I know when I put -8 in, I'm going to get 0. I know when I put -3 in, I'm going to get 1. So this is a function. So yes, this is a function. The domain is simply the domain is also labeled as my inputs. And if I want to use a letter represented by the letter X. So my inputs, my domains are 0, 2, -3, and -8. My range are my outputs, and hopefully you guys can see this. If not, I'm running output, and that's my Y, and that's my range. My outputs are -7, 5, 1, and 0. So let's look down here. When I put in 9, out pops my -7. This is my input, this is my output, this is my X, this is my Y, this is my domain, this is my range. Different names that all mean, in essence, the same thing. So when I put 9 in, I get -7. Do I have any other inputs of 9? Yes, and what pops out? -1. Do you see how with the same input, I have 2 different outputs? That's like putting in a chicken and getting a pot pie. That's like putting in a chicken and getting fried chicken. I don't know what I'm getting, so that is not a function. So no is the answer there. My domains are 9, 4, and -2. I already have 9 there, so I'm going to write it once. My range is -7, 3, 0, and -1. So hopefully that shows you the difference between what a function is and what a function is not. Over here is the function. Here are my inputs because these are my x's. Do I have any inputs that repeat? No, I don't. So I can't tell if they have more than one output. So this is a function because each input only has one output. It's a one-to-one relationship. So is this a function? Yes. My domains are my x's, -9, 7, 0, 3, and -4. My range are my outputs. So that's -2 is my y's, -2, 12, -6, 7, and 12. If you notice here, there are 2 outputs that are the same. That's okay. It doesn't matter if 2 inputs share an output as long as each input only has one output. If I look down here, I have 1, 2, 3, 4, 5. Nothing repeats there, so from what the information I'm given, I can't tell that it's not a function, so this is a function. My domain will be -5, 5, and 15. No, that's not my domain. I apologize. That's my range. My domain would be 1, 2, 3, 4, and 5. My range would be -5, positive 5, and positive 15. Here's my domain. This is my x. This is my inputs. Here's my range, my y. Those are my outputs. So the only time it's not a function when it is not a one-to-one relationship. Let's look at a few more examples and see if we can't make it make a little more sense. So here it just simply says, is this a function? And we have 6 examples here. Is this a function? So the main thing I'm looking for to decide if it's a function right now with a problem like this is I'm going to see if any of my inputs, if any of my x's repeat. If they do repeat, do they have different outputs? If my x's have different y's, if similar x's, if the same x's have different y's, then it's not a function. If they don't, then it is a function. So I have 10. Do I have any more inputs of 10? Nope. -2. Any other inputs of -2? Nope. -6. 5, 8. So nothing here. None of my inputs repeat. So I don't have enough information to say this isn't a function. So is this a function? Yes, it's a function. On my next one, I have -13. If you look, -13 becomes 4. Over here, -13 becomes 9. Put the chicken in. I might get fried chicken. I might get pot pie. I don't know what my output's going to be. This is not a function. On number 5, -4 doesn't repeat. Oh, here's 5. 5 is -9. 5 is -3. The same input has 2 different outputs, not a function. Over here, I have -7 and 4, -7 and 7. Since my inputs repeat and the outputs are different, not a function. Over here, I have 15, -6, -3, and -1. All my inputs are different. That way, I can't tell that they share any outputs. So yes, this is a function. And at the bottom, I see automatically this is not a function because I have a 12 and a -18, a 12 and a +5. I have the same inputs, have different outputs. That is a one-to-many relationship, not a one-to-one relationship. So that is not a function there. Okay? Now I have the same exact thing, just in a table mode. So nothing changes. I'm looking for the exact same sort of information. Does each input only have one output? I look at my x's. They all different. They all differ. That's a function. I look over here. I look at my x's. Ooh, I have a 9 right there. I have a 9 right there. Here 9 becomes -18. There 9 becomes 17. Those are different, so that is not a function. Once again, I have 4 there, 4 there. The same input has 2 different outputs, not a function. Over here, all my inputs differ, so that is a function. Hopefully this is making some sense. In algebra, this is the main thing at this point that we need to know about functions is it a function or is it not a function? Now we're doing a little mapping from x's to y's. So on the left-hand side, this would be my x, my inputs, or my domain. The right-hand side would be my y, my output, or my range. And I'm still looking at every input only has one output. So here, -1 is 8, 0 is 8, 4 is -6, 7 is -2, 8 is -2, 12 is 5, 13 is 17. Every input only has one output, so that is a function. Do some inputs share an output? Sure, that's okay, as long as each input only has one output. If I look over here, my mind automatically goes to -9 right here all of a sudden, very quickly. Do you see how -9 is both +9 and -16? I don't know. Every time I can't be for sure. If I plug a -9 into my function, what's coming out? Is 9 coming out? Is -16 coming out? If I can't be confident that's going to be the same repetitive answer over and over, it is not a function. If I look down here, go to 0 right away. It has 2 different outputs, 0, 17, 0, 19. Put that chicken in my machine. I might get pot pie. I might get fried chicken. I get 2 different things. Not an answer, not a function. And on the last one, you'll see that each input has only one arrow coming off of it, which means it only has one output, which means that this is a function. So yes, no, no, yes. Now we're moving to graphs, and graphs are the easiest ones to tell if they are a function. Graphs are the easiest way to tell, or the easiest ones to determine. That though was first. If you were in school right now, second period just ended, you'd be moving on to third period. With all these graphs, to determine if it's a function, all we have to do is apply the vertical line test. And what that means is if I draw a vertical line, and at any point it touches 2 points on the same graph, it is not a function, because that means the same input has 2 different outputs. So if I draw a line there, it only touches 1 point. So far, so good. But if I draw a line right there, you'll notice that it touches right there, and it touches right there. If it touches 2 points at the same time, it is not a function. If I go to this next one, no matter where I draw that line, if I draw it here, if I draw it there, 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 you will notice that at any point, my vertical line test, I can only draw a vertical line through 1 point at a time on that graph. So this is a function. On this one, very quickly, you see if I draw a vertical line right there, it touches 1 point there, 1 point there. If it touches more than 1 point, it's not a function. So no, this is not a function. This is a straight line. No matter where I draw my vertical line test at, it will never touch more than 1 point at a time. So it is a function. My oval is pretty much my circle, just a little bit elongated and squeezed in the middle. Touches there, touches there, touches there, touches there. Not a function. And here are these sideways parabolas. Quickly, I can see if I draw a line there, it touches there and touches there. So that is not a function. So to review, to tell if a graph is a function, draw some vertical lines. If at any point, so not just 1 point, but if at any point your vertical line touches that graph at 2 different spots at the same time with the same line, it is not a function. If you draw the vertical line and it only touches 1 point on the graph, it is a function. It's simple as that. All right, now we are going to practice writing some functions given a table. And if you're watching this for your homework help, this will be very helpful because these 4 problems are on your homework. I said that. These are your homework problems. So I would highly suggest paying attention to this and writing it down because it will give you 4 correct answers. So what we have to do is we have to write a function. And we talked about in class, if you were here, if not, no biggie. A function is just like it's a relationship between x and y. And it's a rule. And we can use that rule. We can write the rule as an equation, as an expression in a way. And our directions say write a rule for each function, write the function in terms of f of x. And all of f(x) is f is a function of x. So in 7th grade, you should have done stuff like y equals 3x plus 2. When I say write it in terms of a function, we can just do the exact same thing we did, but instead of writing y, we just write f of x equals 3x plus 2. These two are very, very similar. This is just function notation, and that's just more of what we do in 7th grade. So to figure out how to do this, we look at our inputs, and we try to see what happens to our inputs and how they become their outputs. So I know whatever my function is, if I have 5, it becomes 15. If I have 7, it becomes 21. If I have 18, it becomes 54. And if I have 21, it becomes 63. So looking at that, I need to look for some sort of pattern, some sort of rule that shows me how my x's, how my inputs, how my domains become my y's, my outputs, my ranges. And I see right now that all I have to do is to go from 5 to 15 is multiply by 3, and that is true for all other the other 4 sets of data here. So I'm going to write f of x, and to get my output, all I have to do is multiply my x terms by 3. F of x equals 3x. On my next one, same thing. I'm looking left to right. I see 42 becomes negative 14. 33, negative 11, negative 24, 8, negative 51, 17. So I know it's going to be f of x equals, I'm seeing these 2 middle ones right here pretty quickly, that 24 divided by 3 is 8, 33 divided by 3 is 11. So I'm going to say x divided by 3, but I'm not done yet, because if I have a negative, I divide to get a positive. If I have a negative, I get a positive is a negative, and a positive is a negative. So you'll notice the signs of my inputs change when they become my outputs. So not only am I dividing by 3, I am actually dividing by a negative 3, and I'm doing that in order to make these signs change, because a positive divided by negative is a negative, and a negative divided by negative is a positive. So I'm looking for that relationship there. The next two are a little bit harder because they're two-steppers. And we do this, we're still going to look from left to right. And I have to figure out what's going on here. That third one's really kind of difficult. The most difficult here, it's a two-step. So there's two things going on. So not only am I dividing by a number or multiplying by a number, I will then have to add or subtract by a number. So I know it's going to start with f of x. And I know whatever my x is, I'm dividing it. And I know I'm dividing it because my numbers are all getting smaller. And I know it's a two-step because I know 20 divided by 2 is 10. But I know 40 divided by 2 or 44 divided by 2 is not 6. So it's not a one-step right away. I know on this one I am subtracting, and on that one I'm adding. So I know it's not a simple addition or subtraction one step either. So what I have to do in my head is, what can I do to 36 that gets me close to 14? It might not get me all the way to 14, but it needs to get me close to 14. Maybe I divide 36 by 3 to get 12, and then add 2. So maybe my rule is divided by 3 plus 2. But I know that's wrong immediately because when I go up here, I see that I can't divide 20 by 3. I can't divide 4 by 3. So if I know I'm dividing 36 by a number, and I want to get close to 14, but whatever number I divide 36 by, I also have to divide the other numbers by. And the only thing I can think of that gets me close to 14 that is divisible by all those other numbers would be 4. 36 divided by 4 would be 9. To go from 9 to 14, I would have to add 5. That might be right. Let's check. 20 divided by 4 is 5. 5 plus 5 is 10. 4 divided by 4 is 1. 1 plus 5 is 6. Negative 12 divided by 4 would be negative 3. Negative 3 plus 5 is 2. So that is it. That is it. Is it. And there's my function notation. So that's what a two-stepper looks like. I know it's a two-stepper because I try to do some simple one-steps first. That doesn't work. I know a divide first because I see my numbers are getting smaller. I know they're getting bigger here, but we always, if you remember back to 6th grade when I taught you, we look at the biggest pair. The biggest pair usually gives us the most help. All right, last one here. I'm still looking at my functions, look at my rule. How does my left side become my right side? How do my inputs become my outputs? And I see that this is not going to be a one-step because 7 plus 15 is 22, but 4 plus 15 is not 13. So it's not going to be a one-stepper, so I know it's going to be a two-stepper. So then I have to say, okay, if I'm looking at my biggest pair down here, because once again, my biggest pair is my most helpful pair, how does 7 become 22? It can't, but how can 7 get close to 22? I immediately go with times 3. Okay, if 7 times 3 is 21, how does 21 become 22? By adding one more. So 7 times 3 is 21, plus 1 is 22. 4 times 3 is 12, plus 1 is 13. Negative 2 times 3 is 6. Negative 6. Negative 6 plus 1 is negative 5, so it does check out. So those are the rules for those 3 functions. Make sure, once again, if you're watching this video, these are your 4 homework problems, 4 of your homework problems. I'm not doing the whole worksheet for you, but we did not have a chance to talk about this on Wednesday, so I'd highly suggest you watch this and pay attention to this. All right, last thing, this is about functions in a different, I would say in real life. I don't know if you ever think of this as a function in real life, but it's a good little thought experiment for us. Is we're going to say, okay, is there a one-to-one relationship for everything in these real life scenarios? And it says city to zip code. Does city to zip code, is that a function? So what that means is every city is addressed with only one zip code. And you gotta be careful. We live in a small town. And honestly, I'm not for sure what the zip code for Clinton is, but I know where I live, Terre Haute. When I grew up in Terre Haute, I lived in the zip code 47805. And then when I moved to my apartment, when I first got married and got out of college, I lived in 47803. And now where I live in West Terre Haute, it's 47885. So you notice I've lived in 3 different parts of Terre Haute, and each part has a different zip code. So that's 1 city to 3 zip codes. So that is no. Now, I'm not going to write down the explanation because I just said it out loud there. But yeah, because not every city has exactly 1 zip code. Some do, but not all. Okay? Does every last name have the same first name? Is that a one-to-one relationship? That one last name, one first name? That is also no. Because if you think about my family, I'm Matt Sebastian, my son Case Sebastian, my daughter Ellie Sebastian. Every last name has, it's not a one-to-one relationship because the last name can have different first names, so it's not. Does every person and their birthday, is that a function? The answer to that is yes. Every person has one birthday. The person to the birthday, that's a one-to-one function. And does every state only have one capital? That would also, I'm not for sure why it's formatted this way, is also yes. Indiana has Indianapolis. We don't have any other capital, so that's a one-to-one relationship, not a one-to-many relationship. So hopefully this helps. This is also in your homework, so you can listen to my explanation. You need to write that down. I didn't, but you heard me say it. Here are the answers to that middle part. Besides that, you need to do the rest of it. If you have any questions, please reach out and contact me. Hopefully this helped. Besides that, you guys will be hearing from me soon. Have a great day, and I will talk to you later. See you guys.